General DAS Hardware Integrated Machine Use Guide. Thank you for choosing the Universal DAS hardware machine of Guilin Guangyi Intelligence. After receiving the device, follow these steps. First, check out the box. 1. Make sure the packing is in good condition. 2. Check the goods according to the invoice. A user's manual. A software quick use manual. A product test report. A certificate of conformity. A 3-core power cord. A set of equipment. Test accessories: 2 discs of 1 km single-mode fiber, 1 roll of 30 fiber jumper, 2 fiber flanges. 3. Check the appearance of the equipment. Product label on the right side of the equipment. Check that the product model is consistent with the model of the equipment you purchased. There was no abnormal damage to the appearance. Four. Shaking equipment. Confirm that there is no abnormal sound inside the chassis. Second, device connectivity. One. Connect the external sensing fiber. Remove the optical fiber flange dust cap of the equipment. Connect the device: 1 km single-mode bare fiber, 30 single-mode fiber jumper, 1 km single-mode bare fiber in turn. Pay attention to the notch. Two. Connect external power supply, AC 220V. Connect one end of the 3-core power supply to the 3-hole socket. Connect the other end of the 3-core power supply to the equipment power interface. Third, power on and start. After the power is connected, the LCD screen of the device lights up to indicate that the device has entered the working state. Note, if not, please check whether the power cord is plugged in tightly. Fourth, equipment delivery information introduction. Drivers. Includes acquisition card driver. DAS integration module serial port driver. Both include driver installation guide. Two. Host computer. DAS integration module control software _dual DVS. Used to control the output of the device light, factory to adjust to the best state, user default parameters can be used. DAS function demonstration software DXSGY card 1V31. The included functions include all-fiber demodulation, real-time RBS curve, real-time language restoration, real-time spectrum, real-time DAS waterfall diagram, real-time fiber vibration curve, and data saving. 3. User manual. Universal DAS Demo Software Quick Use Manual, GYDAQ 2480 User Manual. Universal DAS Hardware All-in-One User Manual. Note: please read the above manual to smooth your development process. 4. Schematic diagram of hardware connection. Contains a schematic of the connection to the internal hardware of the device. 5. Secondary development. Includes Windows, Linux acquisition card interface and call routines. 6. Common problems and solutions. It contains answers to common questions in the process of customer development. Data reading routines. It contains reading routines for single-point data, amplitude data, and fully demodulated data based on Python, which can read the data saved by DAS function demonstration software DXSGY card 1v31. 5th, the use of the host computer demonstration DAS integrated module control software _ dual DVS. Select the serial port. Open the serial port. EDFA switch. To control the opening/closing of the optical output of the EDFA module in the device. 4. Raman switch. To control the opening/closing of the optical output of the Raman module in the device. EDFA current setting value less than or equal to 300. Raman current setting value less than or equal to 2500. DOA setting value less than or equal to 2500. 6th, the use of the host computer demonstration 2. DAS function demonstration software DXSGY card 1v31. The sound source was placed at the 30M fiber jumper. 1. Software interface. Acquisition parameter setting area. 2. Demodulation parameter setting area. Real-time RBS curve. Real-time language recovery curve. Real-time spectrum. Real-time DAS waterfall diagram. Real-time optical fiber vibration curve. 2. Collection parameter setting steps. Click Stop Ingest. 2. Check the actual length of your external cable. 3. Setting resolution. Generally set 2M, other settings refer to 1.3 resolution in the quick use manual of the software. Calculate and set the number of samples. Sampling points equals actual cable length, m/resolution, m. Note, the number of sampling points must be a multiple of 256. If the result is not a multiple of 256, it should be rounded up to the nearest 256. 5. Set pulse width, generally set to 100 nanoseconds. For other settings, refer to the 1.2 pulse width in the quick use manual of the software. 6. Calculate the pulse frequency. Pulse frequency, hertz, less than 1 times 108 sampling points times resolution. Note, the calculated results are the maximum pulse frequency, and the actual setting value should be less than this frequency. In order to reduce the amount of data, the user can choose the appropriate pulse frequency according to the demand. Click Start Ingest. Three. Collection parameter settings. 1. Click Stop Acquisition. 2. Set up demodulation threads. 12 generation i5 processors usually set up 6 threads. 3. Set the demodulation position. Set according to the position you need to view. 4. Set the demodulation range. The demodulation range needs to include the vibration source. Click Start Collecting. 4. Real-time RBS curve. Represents the scattered light intensity distribution at each position along the length of the fiber. The x-axis is the fiber position, and the y-axis is the light intensity, relative. The RBS curve is obtained by averaging 100 times the amplitude data of the acquisition card. 5. Real-time audio demodulation curve. The real-time audio demodulation curve of a point on the optical fiber. The point is determined by the demodulation position and the demodulation range. The x-axis is the sampling point. The default is 10,000 sampling points. divided by the pulse frequency to convert to the displayed time range, and the y-axis is the phase magnitude. The curve is normalized by dividing the phase data at a point on the fiber by 256. 6. Real-time spectrum curve. The spectrum curve of a point on the fiber, determined by the demodulation position and demodulation range. The x-axis is frequency and the y-axis is frequency amplitude. The curve is obtained from the phase data of the real-time audio curve by FFT. 7. Global DAS waterfall diagram. The global DAS waterfall diagram fuses the information of location, time and vibration intensity in a single graph to visualize the data table. The waterfall plot is obtained by dividing the 100 pulse phase data by 256 and normalizing, first squaring and then taking the average, which is the average phase energy. 1. The x-axis is the location of the fiber, the location of the vibration event. 2. The y-axis is time, duration of the vibration event. 3. Z-axis is vibration intensity. Vibration intensity mapping is carried out according to different colors, which can be set through the color bar on the right side of the window. Eight. All-fiber vibration curve. The all-fiber vibration curve fuses the position and vibration intensity information in a single graph to visualize the data table. The curve is made from phase data. 1. The x-axis is the location of the fiber, the location of the vibration event. 2. The y-axis is the vibration intensity. The vibration intensity of the vibration event is characterized by the amplitude of the curve. 9. Play/turn off audio. The playback audio button is darkened for the off state and highlighted for the on state. 10. Data preservation. There are 3 possible types of data to store. 1. Single point data, double type, the phase data of a point on the fiber after demodulation, corresponding to the yellow curve in the real-time curve. 2. All-fiber demodulation data, double type, phase data after all-fiber demodulation, corresponding to waterfall diagram and all-fiber vibration curve in global demodulation. 3. Amplitude data, unsigned short type, all-fiber amplitude data, corresponding to the green curve in the real-time curve. 4. To save data, the button darkened is closed, and the button highlighted is open. 5. The saved data file is in the DXSGY card 1v31 folder, and the file is a binary file of year month day hour minute second -bin. 6. The saved data can be read according to the data reading routine based on Python provided by our company. 7th, the use of equipment precautions. 1. When the equipment is not in use, please use the DAS integration module control software to turn off all switches. 2. When the device switches on, do not plug or unplug or select the fiber connector. It will damage the equipment, and the equipment should be returned to the factory for maintenance if damaged. 3. When connecting the external sensing fiber, pay attention to clean the fiber connector and use the FC/APC connector. 4. Good equipment use environment and habits can greatly extend the service life of equipment. Sound restoration test. Acquisition parameter settings. Refer to video host computer demonstration 2. The sound source position is determined according to the all-fiber vibration curve, and it can be seen that the starting point of the sound source position is 518 and the ending position is 535. So the demodulation position is set to 518 and the demodulation range is set to 20. Click play audio. Bare fiber disc sound reduction display. Leather fiber optic sound reduction display. Vibration reduction test. Acquisition parameter settings. Refer to video host computer demonstration 2. All fiber vibration curve and waterfall diagram do not need to set demodulation parameters. Turn on the vibration source. Light path connection display and actual vibration reduction effect. Frequency reduction test. Acquisition parameter settings. Refer to video host computer demonstration 2. The signal generator was used to set the PZT modulation parameters. The waveform was sine wave, the frequency was 200 Hz, and the amplitude was 10 V. Turn on the signal generator. The PZT position is determined according to the all-fiber vibration curve. And it can be seen that the starting point of the PZT position is 503 and the ending position is 518. So the demodulation position is set to 503 and the demodulation range is set to 15. Optical path connection display and actual frequency reduction effect. Sine wave, frequency 200 Hz. Display of connected devices.